Elon Musk dropped the Cybercab production announcement this morning with almost no ceremony, just a short video and a caption. But beneath that quiet reveal is one of the most significant AI deployment events in recent memory. This isn't just a new vehicle rolling off a line. It's a bet on a fundamentally different approach to machine perception being validated at industrial scale. Traditional automakers typically need a decade or more to move from concept vehicle to full production manufacturing. Tesla has now compressed that cycle multiple times, with the Model 3, the Semi, and now Cybercab. What looks like corporate velocity from the outside is actually a deeply unusual organizational capability. Most hardware companies simply cannot iterate this fast without sacrificing quality control. And Tesla appears to have cracked that trade-off in ways competitors are still scrambling to understand. Every single Cybercab operating on public roads is essentially a mobile inference engine. The vehicle is continuously running a vision-based neural network that processes camera inputs and makes thousands of real-time decisions every second. Lane positioning, pedestrian prediction, gap acceptance at intersections, and countless micro-judgments humans make unconsciously. The car is just the chassis. The product is the model running inside it. When Tesla publicly abandoned LiDAR and radar in favor of a pure camera plus compute approach, the autonomous vehicle research community was deeply skeptical. LiDAR provides rich 3D spatial data that cameras struggle to replicate, especially in low light or adverse weather. Tesla's counter-argument was that the human visual system navigates the world entirely through cameras, our eyes, and that sufficient compute and training data could close the gap. Shipping Cybercab at scale is essentially Tesla saying, "We believe we've closed it." Laboratory benchmarks and closed-course testing tell you almost nothing about how an AI system performs at the long tail of real-world complexity. The genuine stress test for Cybercab is a confused left turn at a chaotic urban intersection in Cleveland in February, not a sunny California highway. Edge cases involving unpredictable pedestrians, unusual road markings, flooded streets, or erratic human drivers are exactly where vision-only systems either demonstrate genuine generalization or reveal dangerous brittleness. There is no leaderboard for that. Here's where the real strategic depth of this announcement lives. Every Cybercab added to the fleet is a new data collection node, surfacing edge cases that the model has never encountered before. Those edge cases feed back into training, improving the model, which expands the operational design domain, which allows more deployment, which generates more data. This is a compounding flywheel that accelerates over time. A competitor trying to match Tesla in 2028 won't just need better hardware, they'll need years of accumulated fleet miles that simply cannot be manufactured. It would be easy to evaluate Cybercab as a product and ask whether the robotaxi economics pencil out, whether the design is appealing, or whether pricing is competitive. Those questions miss the strategic point entirely. Any sufficiently capitalized company can build an electric vehicle. Very few organizations on Earth can build a continuously improving autonomous driving model trained on tens of billions of real-world miles across diverse global conditions. That data asset and the engineering infrastructure to turn it into model improvements rapidly is the actual competitive barrier being constructed right now. It would be a mistake to read Cybercab hits production as the conclusion of a story. It's actually the opening of the most important chapter. The prototype phase tested whether the approach was technically feasible. The production announcement confirms Tesla believes it is. What happens next? How quickly the model improves across diverse geographies, how regulators respond to fleet-scale deployment, and whether the data flywheel compounds as fast as the theory suggests will determine whether this moment is remembered as the beginning of the autonomous vehicle era or a cautionary tale about overconfidence in AI systems.